And I was asked to talk about the benefits of digitally enabled collaboration, which I will do, but via talking a little bit about what smart infrastructure is and what it might mean and so forth. But before I do that, we've already talked about this really today, but I just wanted to set in context the fact that our infrastructure faces many challenges, and we've heard about a lot of that from Tim this morning, from Caroline. It's ageing, it's in uncertain condition. We often don't have good design information and history for particularly our older assets. We're loading them ever more heavily, and they're facing a lot of uncertainty in terms of things like climate change and population growth and that sort of thing. So that means that we have implications for not just how we design our new infrastructure, but also how we operate our existing infrastructure, how we maintain it, how we keep people safe while using it, maintaining it, operating it, etc. Which means that innovation is really necessary. But it's also very challenging in our industry because of the things that various people have talked about this morning around the appetite for risk being low. Tim mentioned the fact that if something goes wrong with our infrastructure, it can impact a whole city system. So if something goes wrong with an aeroplane, that's very bad for a small number of people. If something goes wrong with the power supply to a city, as New York discovered during Storm Sandy, that's very bad for lots of people. We are inherently reluctant to innovate because of the risk of getting things wrong. But also, particularly in the UK, we have a very complex structure to our industry, which means that there are many players involved in needing to deliver many innovations, and that often the value captured from an investment in innovation is not captured by the people that made the investment in the innovation. So there's a sort of a split incentives issue as well. So while innovation is necessary, it's quite challenging for us to do. And that's one of the reasons that we were set up, because Tim said this morning, all these good things are possible, but we need to make them happen. And actually, there's a bit of a market failure in some of this because of those challenges. So part of our role, alongside many other organisations, is to help address that market failure and really help demonstrate where innovation can help. We're called the Centre for Smart Infrastructure and Construction, and various people talk about things like smart infrastructure. So in the same way that Caroline defined resilience, I'd like to define what I think smart infrastructure is. So for us at least, and for colleagues in industry with whom we wrote what I call the orange paper, which you can find on our website, which is around the benefits of smart infrastructure, our definition is that smart infrastructure is what you get when you use the digital to manage, operate, design the physical. I think there's quite often a danger in the discourse around smart things that we think that an app will solve the world's problems. We forget that the app has to be applied to the real physical stuff around us. So it's very much that intersection of the physical and the digital. In our world today, unfortunately, things look a little bit more like that. But I have faith that in the future they will look a lot more like that, and that we will harness the sort of data revolution that we were talking about earlier to make good things happen. But we need to take ourselves on that journey, which is challenging, as I said, in our industry. There are lots of reasons for doing it, though. One of them is that it's a smart way of adding value. So if you look at this, sort of imagine that the y-axis is value of infrastructure around us. However big the investment is in Tideway or HS2, it's a very small increment of the total value of the infrastructure we have around us, which is vitally important to everything we all do every day. So we can make a big investment here, but it's really only going to impact this bit unless we're clever about it. This stuff carries on in the condition it was in. But if we invoke investments in smart infrastructure, whoa, something odd happened there, we can actually add value across the whole of infrastructure, because we can start to use the digital to understand the condition of our existing infrastructure, get more out of our existing infrastructure, as well as getting more out of our new infrastructure. So it's really about making the most of what we've got around us. Certainly in this crowded little island, we can't purely build our way out of capacity constraints. We've got to be smarter in how we use the infrastructure we have around us. So there's an imperative for picking up on what was talked about in the last talk before coffee, and actually using the data better. Now this is a bit like something we've seen before this morning. It's good to see consistency. Mine is slightly different, but it's along the same principles. So this is another kind of data value pyramid, and all sorts of people articulate them. But really what the point of this one is that down the bottom here we have all of these data sources. And there's all kinds of data sources. So it's everything from GPS signals from people's phones, through to laser surveys and satellite imagery, through to information about customer billing and gate controls on ticket lines and that sort of thing. All of those are potentially useful sources of information about our infrastructure. We have even used in CSIC social media data to understand how infrastructure is being used and the kind of the loading on the infrastructure in terms of users. So that's fantastic. But as we discussed before coffee, it's only any use if you can do something good with it. And to do that, actually, there's quite a lot of curation and sense-making, data management that needs to be done on the data. I think it was Paul just before coffee was saying that, we need to sort of start at the top of the pyramid more often and think about what's the information we're trying to find in this data lake. But we also need to, at the bottom of the pyramid, think about, with the data I've got coming in, how do I curate it and pull it together in a way that makes it useful and usable? We then need to make sense of that data. So we've got it structured in a way we can access it. We need to make sense of it. And in there comes all of the things around modelling, data analytics, data mining, big data approaches to things. And then we need to use that to help us with decision making. And there's still a role for the digital in the decision making, so we can have decision support tools, rule-based automation, all those kinds of things. And sometimes decisions are made instantaneously by machines, so often in a safety case, things will happen automatically. Doors will close, alarms will go off, etc., etc. In other cases, that information still needs to be presented to a person, luckily for all of us, in order for them to make a decision. But it's the decision ultimately that's important. So data is an irrelevant thing unless you're using it to make some kind of decision, whether that's a decision about which tube line you get on to go from A to B, or whether that's a decision about which investment you make in flood resilience and resistance. So as we go up the pyramid, we have a decreasing volume, but an increasing value in what we get. And importantly, we get, as we come up the pyramid, we get improved insight and we get improved decisions, but we also get learning that we should be feeding back into the system the whole way through. So that's a kind of fundamental thing in terms of smart infrastructure that we need to cotton onto. And I think in terms of what I was asked to talk about, which is collaboration and that sort of thing, the real value is in this learning loop and the fact that we can share that data with each other. So for us, the other part of the definition of smart infrastructure, it was said this morning, in fact, is better decisions faster for the benefit of the customer and the end user. So it's all about that decision-making process and why you're making those decisions. And I keep pressing this mouse button wrongly. What does smart infrastructure look like? Well, in one sense, it's sensor-enabled infrastructure. So this is a picture that was put in an article in The Economist back in 2010 when our centre was just about to be set up. And they interviewed Professor Robert Mayer, who's my boss. And the question that they posed was, if a car is intelligent enough to tell us when the brakes are about to fail or the oil's low, why can't we do it with our infrastructure? So the idea is that you have sensors in the infrastructure, you have sensors in the buildings, you have sensors in the machinery that might be building or using the infrastructure. And all of that is talking to each other and communicating with some massive hive mind, which is enabling good decisions to be made. And there's a surprising amount of the technology already available to do that. The challenge is the cooperation and collaboration part. So I'm going to talk about things around how you might use this sort of smart infrastructure approach through the lifetime of an infrastructure asset. So I'm very much, sort of moved away from the big system of systems across a city that Caroline was talking about, and I'm thinking now particularly about infrastructure and the system of systems that might be the infrastructure. But just to give you some examples of the things we're already doing and other people are already doing as well, to sort of start to extract some of that value from this sort of digital collaboration, digitally enabled collaboration. So the way we think about it in CSIC is that you've got, as we carve it up, and you can do this a number of ways, 4 key aspects to an asset's life. You've got, sort of starting over here, and then I'll come back over here, you've got the city in which infrastructure is embedded and that it serves. And it's not just the city, it's the intra-city areas as well. But that gives the infrastructure its context. That sets the demands on the infrastructure. And that's what helps us decide what new things we need to build or where we make our new investments. Once you've got those decisions, then you can look at performance-based design. So we have a lot of finite element models, for example, of things like bridges. Until recently, we haven't had the technology to enable us to actually go back and calibrate those models. So they're based on a lot of good engineering insight and quite a lot of conservatism, because none of us want the bridge to fall down. But now we're in a position where actually we can measure the performance of that bridge, and I'll show you a little bit of that later. We can also transform the construction process, so we can make it safer, we can make it quicker by using monitoring systems. We can also make it better documented, and I'll talk a little bit about that. We can transform how we manage and operate our infrastructure, because we can get more like real-time information. We can gather the data that we're currently missing on our existing assets and start to understand how they're performing, what their history might have been, and what the issues are with them now. And then we can use all of that again to feed into what we're doing at the city scale. But all of that is supported by the sensor systems that we might use, which, as I say, is everything from a strain gauge on a bridge up to satellite data to our mobile phones, the data-driven decision-making piece, and then understanding what the value of those smart solutions is. And I think part of the market failure at the moment, it's not a failure of technology availability, it's actually a challenge in expressing the value and enabling that to be captured and understood in a world that we operate in, where sort of 2% profit margin is seen as quite a good thing, particularly in the construction industry and even in the utilities. You know, I remember a nice Daily Mail headline a couple of years ago about, British Gas have made 7% profit out of us. Well, Rolls-Royce would like to make 50% profit, but nobody frowns at that. But in the regulated industries, regulated utilities and in construction, there isn't enough profit to be taking big risks. So we really need to understand the value. Oh, hello. So looking at performance-based design, just an example of some work that we did on Crossrail, where this is Liverpool Street, this will be Liverpool Street Station. It looks a lot more advanced than this now. This is one of the running tunnels, and you can see here some sort of circles. Oh, hello. This is running automatically. So you can see some circles, and this is where the cross passages are going to be punched through. Can I escape from this and stop the animations?
Yeah.
I can't keep up with myself. Actually, I'll just go back. Oh, is it? There you go. That's why, because I'm waving my arms around. I'm a bit too Italian, although I'm not Italian at all. So we've got this exciting looking cavern, and this photo was taken by one of my researchers who's a very good photographer. But you've got the two circles here, which is where the cross passages are going to be punched through from the passenger tunnels, because without that you can't really, there's no point having a platform. And traditionally what happens here is so the running tunnels are cut with a tunnel boring machine, but the platform caverns are excavated and then they're covered in spray concrete lining, and then where you're going to punch things through, you need to reinforce it, because people are very worried about the increased stresses that imposes. Spray concrete is a very badly understood thing. It's a very nasty and dangerous thing. So the finite element models as to how much reinforcement you need in the area around the cross passage are quite conservative. So that's where the holes are going to be punched through. And then this is a picture of the cross passages. So what we've done is we've instrumented around this using fibre optics on the reinforcing cage in order to get strain measurements of what's going on there. And what we found was that the reinforcement comes all the way out to here, but actually the strains only develop over about the first 3 metres from where the cross passage comes through. So there are lots of implications there in terms of money saving, and we think that had we had this data beforehand, because hindsight is a wonderful thing, we could perhaps have saved £1 million at Liverpool Street, just in terms of saved materials and saved time. Added to which, of course, you've got reduced risk because you're not exposing people to spray concrete processes for as long. But also we'll have a much better understanding of how these things work. So taking these things forward and passing that learning on to the next project is an important piece of the collaboration. So, I mean, we're looking at ways that this might perhaps be used on Crossrail 2 or even on some of the HS2 platforms. Because obviously you don't change the design codes based on one test point. In terms of transforming construction, there's a range of things that we've been involved in, and others are doing similar things. So the top picture is actually related to Crossrail again, but it's where the post office tunnel runs across the top of the Liverpool Street Station cavern, and the excavations actually came close enough to uncover the bottom of the cast iron in the post office tunnel. So we were monitoring that to understand how it performs, because it's very like a lot of London Underground tunnels of a similar era, and there's a lot of excavation and works happening in London. So what can we learn from this one for the next one? The picture at the bottom I quite like. That is a shaft excavation, again associated with Crossrail. But what we were doing there was using computer vision to basically capture the volume of that shaft each day, so that we could actually have an automated way of capturing volume of material being removed from site. So that's a way of tracking construction progress. It's also a way of, looking at things like how many trucks do you need to be going down those roads at that point in time in a congested city. And we've also done quite a lot of work looking at BIM and how you integrate BIM with the construction process, and also how you integrate BIM with monitoring data. So this is an example on a bridge up in Staffordshire, which it's a Network Rail bridge, and we instrumented the various components of the bridge before they came to site. So we had some concrete beams that were instrumented at the factory yard. We instrumented various bits of the deck. We instrumented sleepers. We've got information from the construction process, but also we've now got loading information with live trains running across the bridge. Now, the power of that is not just that you can do a performance-based design calculation on your design, and you can look at how the construction process might have affected the capacity of the individual elements, but you can also start to use that as a kind of health passport going forward for the bridge. You can use it to monitor it through time, should you wish to. Which brings us to the next thing, which is managing and operating the infrastructure. So a lot of these things, they don't just apply at a single point in the life of a structure. You can get value out of them throughout the whole. So in managing and operating infrastructure, looking at kind of the opposite end of something's life, this is a viaduct up in Leeds that we've been looking at. It's a rail viaduct. It currently has a 20-mile-an-hour speed limit on it because it's in a fairly dicey condition. When the train goes over, you can see the water weeping out of the cracks, which is quite fun. One of my colleagues has done a lot of work on this, looking at... actually, I'll go back one quickly, if I can. One of the things that they did was there are these kind of weird little relieving arches in there, and because we've no drawings for it, we've no idea why they were there, but they were built in it at the beginning. And there are some cracks radiating from here. So the engineers, based on no means of actually monitoring anything very much, thought, well, we'll fill that in with concrete because that'll help. But actually what we found out in assessing this, and we put fibre optic strain sensors around it, we used videogrammetry to understand how the bridge was moving, etc. What we found was that there's a number of cracks and there's various things happening. So we've got this component here that's rocking as trains go over. We've got various cracks that are opening and closing. Some of the cracks are being filled with grout and then they're cracking again. And what we found was that actually, although the relieving arch was kind of part of the cause of the problem, filling it in wasn't helping at all. So you're giving yourself a bit of false hope there, and you've spent money that you needn't have bothered spending, really. So although we don't have good information about assets, we can use monitoring and our engineering insights to start to understand them and start to infer back what might have happened to this structure, what's happening with it now, and therefore how much more life it's got. Actually, does it need a 20-mile-an-hour speed limit? And actually, for this bridge, with the kinds of trains it has going over it, we are reasonably confident that it's not the speed that's the issue, it's the number of trains. So actually, that 20-mile-an-hour speed limit might be unnecessary. So the impacts that has on operation and so forth could potentially be avoided. Obviously, again, Network Rail want a bit more evidence before they're willing to take a speed limit off. But it's those sorts of insights that can help unlock log jams in our infrastructure and get more capacity out of it. So that's just a bit of some of the instrumentation that we looked at, and this shows some of the rocking mechanisms that are happening in the arch. There's also some weird behaviour happening through the arch where the front is moving towards you and the middle is moving away from you. And for a while, my colleague had exactly the look on his face that Caroline just had and said, I don't think I believe in the videogrammetry evidence. But by then looking at that alongside all the other evidence he had and modelling the bridge in different ways, he found out that actually this is real and it is happening, and it's to do with how the sort of the weights of the train come over the bridge. So a lot of insight can be got from that kind of information. Woo. Something else we've done, and this looks a little bit like some of Caroline's stuff, and in fact we're talking to Buro Happold about how we might embed this in their tool, is look at infrastructure future-proofing. So again, this is a subset, if you like, of the sort of thing Caroline was talking about. This is an example of Liverpool wastewater treatment works, which are being expanded at the moment. And we work with Costain, who's the contractor there, to look at, for various issues that are important to them, how what are the future issues that they need to be potentially resilient against, and then how future-proof are they against those issues, and how future-proof would they like to be against it. So again, you don't have a perfect circle of 100% for everything. You have a variety of different requirements, because if you've got something that you can easily replace, like a pump, for example, it's kind of, the fact that you can put it in and take it out might be enough, although that was a bad example because actually there's quite a big gap there. But, so there are some things where you don't need to be massively future-proofed because you can just swap them out. There are other things where, if it's your flood wall or something, you might want to think quite hard about sea level rise for the next 50 years. So really, in terms of managing and operating infrastructure, it's about getting the data, understanding the asset behaviour, and then having the ability to make decisions about how you operate that asset. So what I haven't included in here is some work that we've done, for example, about, if you've got a road bridge and you've got 5 things you need to do on it, they all have different points at which it would be most economic individually to make those interventions, but you're also influenced by the fact that you have a wider challenge around it costs you to shut a lane on the road, for example. So you can create a decision-making tool based on understanding the condition of the asset, which is the big data gap we have at the moment, and understanding the costs of the repairs and the costs of the ancillary things around it that might make you decide to either delay a repair or to do another repair earlier. So it's sort of, you go from what do I know about my assets to what does that mean in the bigger context? And you can then go from that to I've got 25 bridges, I can only afford to repair 3 of them, which ones are most important to me? Which I think is a fairly common problem in a lot of local authorities. And then finally, smart city systems. I mentioned that we use all kinds of different data here. I've just got one example to talk about, but this is a colleague of mine. For those of you that can't spot it, this is London. She's currently developing a fairly simple model because, again, we're challenged with the data availability. What she's looking at here is putting together things like understanding of the geotechnical underpinning of the ground, what work has been done there before, to look at the transport network, so the road and the rail network, and to overlay with what we know about the kind of the prehistory, what we know about the condition of that asset, and what we then know about the usage of it, to start to infer some deterioration models, which is the kind of thing that can then feed into what I was talking about before in terms of decision making. So there's 2 ways to get to deterioration models. One is to monitor something and see how it's deteriorating, which is great for that asset, but kind of takes a while. And the other is to start to use some modelling systems to actually come back and say, well, okay, I know that this is being used this much. What's its deterioration likely to be? Oh, and actually, if I close this road, it's going to divert traffic over here. What impact is that going to have on that part of the network's condition? So with a bit of luck and a following wind, we might actually get to see the... No, we didn't. There is a little video that plays, but it might not have... There we go. Yeah, so it's very simplistic, this, but a little bit of the network, and you can start to see how, with traffic going over it, the colour of the network starts to change. So as the colour gets more intense, that's indicating some sort of degradation, and then as you make an intervention to repair it, the colour becomes less intense. So this is modelling over sort of 20 years what might be happening with that bit of road. It's simplistic at the moment because of the lack of data, but if we could get good data, imagine the power that would yield to people trying to plan infrastructure interventions. There's another slide. So I hope that's given you a bit of a window onto the ways that by collaborating, sharing data, and so thinking about these things more holistically and more broadly, we can bring a lot of value to our infrastructure networks. The thing we all struggle with at the moment is availability of the right kinds of data. One of the challenges, I think, you found it in Beirut, but we find it here, is that people either don't gather the data or they gather it in very inconsistent ways. So, for example, I've talked about bridges this morning, but to take that as an example, with bridge inspections, we still send people out with clipboards to take notes and stuff. We still, once a year we have an inspection where you have to be near enough to see it. And once every 6 years we have an inspection where you have to be near enough to touch it. That's not good data, but we now have the technology around us to at least be able to make those clipboard inspections, straight onto an iPad or something that can then spew the data straight into an electronic system rather than the poor guy having to go back and tap it all in. But at the best, what we can do is add additional monitoring. So using satellite data, we're looking at using satellite data to understand ground movement in structures and understand how that might affect them. You can pick up... I seem to be talking only about bridges today, but we don't only talk about bridges. But you can pick up if bridge bearings are locked. So the Hammersmith City flyover, we might have been able to spot that before the chap who was hearing the wire pings, fortunately intervened to get the bridge shut. So there's a range of kinds of data we can use in a range of different ways, as long as we all think about what data do we need, how do we gather it, and how do we make it accessible, which I think kind of fits neatly with the talk before lunch. And that, as I say, is a smart way of adding value to our infrastructure. And I think that's it. Yes, thank you.
Thank you very much. Cheers.